All right.
Or live on Twitter.
So at some level we are live.
Okay.
Hello.
Hello, William. Good to see you again.
Good to see you too. Welcome back.
Thank you. It's good to be back in San Diego.
So where have you been these past these past months?
Past month and a half, I've been over to France for a friend's wedding, and then mostly hanging out in the Bahamas, doing a little shark diving.
Fun.
Absolutely. But yeah, it's good to be home. So, exciting show today. Complicated show, yes?
I think so. It's supposed to be. Last week we had these advanced questions here on our list that someone had asked us, and Paul's like, "Oh, well, you should answer those next week." And I said, "Oh, sure, I'll do that." And now I'm on the hook to answer advanced questions.
Which is great. So I didn't do the research, so I'm on the hook to ask the advanced questions. We'll go with interview style again. So do we want to go right out of the gate onto the advanced questions here?
I suppose we could do that.
All right. Well, let's start at the top. Talk to me about the difference between proof of work and proof of stake.
Well, let's see here. Proof of stake means you went to a fancy restaurant and you ordered the prime rib. Proof of work means you were in the kitchen of that restaurant preparing the steak.
Okay.
It's very simple.
Okay. So metaphorically speaking, it's all right. I would have gone down that road too.
So in cryptocurrencies, we have a very big problem. And that's that I, as a user of a cryptocurrency, can produce two transactions which independently are valid. I can say I have one Bitcoin, and I'm going to send one Bitcoin to you, and I'm going to send one Bitcoin to Paul. Well, they can't both be valid at the same time, even though independently sending a Bitcoin to you is a valid operation, sending one to Paul is a valid operation. But at the same time, because I only have one coin, I can't do both. So how do we agree, or what mechanism do you use to choose between two conflicting transactions? There's nothing invalid about them. They're just conflicting with each other.
Okay, so
there's some methods you could use to do that. One would be to say, we will pick a king, we'll pick Visa, and Visa gets to choose which ones go through and which ones bounce. That's what your bank does, right? They see two conflicting checks. You wrote two checks out of your account. You don't want to be centralized. We don't want any one person to control the network. So how do we choose without having anyone in charge? Another mechanism that's used by things like Ripple is you have a vote. There's a consensus voting mechanism. Everybody who's involved has an ability to say something based on the fact that they're involved. And you trust certain people to vote and be part of your network.
So does the network automatically votes in the background?
Yeah, that's how they choose between conflicts.
So the network somehow knows that
So
William really meant to send me the Bitcoin and not Paul?
So in the Ripple network, you have computers that trust each other. They're set up. They join the Ripple network, and they say, okay, I kind of know who you are. I kind of trust you. And then if I have this conflict to say, well, what do you think about this? Well, I think that Alan should get the money. Well, I agree that Alan should get the money. Okay, now he gets the money and not the other person.
Okay.
So it's based on membership in the network. I may be butchering that. I read the paper a while ago, and I don't know all the details, but that's my understanding of the Ripple consensus mechanism. I should probably reread it and give you better details. If anybody thinks I got it wrong, let me know and I'll research that. But there's another way to do it, and that's to say we're just going to have a lottery.
Okay.
And the lottery is going to pick somebody who gets to choose the transactions, and then they have 10 minutes of power, and then they're taken off, and then we do another lottery for another random person who gets to pick which transactions are valid or not.
Okay. So
we have a temporary leader. We don't have like a permanent leader. Like the power is fleeting, because as soon as you win, you get to do the thing, and then you're kicked out, and you have to try all over again.
So that happens within the life cycle of one block being processed.
Right. Every 10 minutes, Bitcoin has a lottery. Who gets to pick the next block? And when you pick the next block, you say which transactions went in and which did not.
Okay, so you would evaluate those two transactions, saying,
right.
Okay, there's only one Bitcoin here. He can't spend both.
Right. So as the miner, I choose to put this one in and not that one.
So how does that ever allow for correctness?
Well, I mean, they're both correct options, right? It's like you can have tacos for dinner or you can have burgers. They're both correct options. Like there's nothing wrong with either of them. It's just you just got to pick something.
Gotcha. So there's no way to measure the user's intent.
Right.
Okay.
There are attempts to make that more clear, right? Like there's the rule in Bitcoin where it was first seen. So the first transaction seen would be preferred by the miners. So that would say, I sent the money to the merchant first, and then something went wrong in my wallet, and I accidentally sent it to somebody else. Well, the first one that went through should probably be the better one.
Gotcha.
So the question is, how do we distribute lottery tickets to this
Okay.
process? And that's the difference between proof of stake and proof of work. Proof of stake, you literally buy the lottery tickets. You put up money, actual Bitcoin or Bitcoin doesn't have proof of stake. So in the case of Cardano, you'd put up Cardano coin or whatever. That's a proof of stake coin. And you win the lottery if you get picked randomly based on the fact that you bought a ticket, and then now you can choose a block. Or Decred's another proof of stake coin. For proof of work, the way you enter the lottery is to do a hash, a cryptographic mathematical thing. And if you're lucky enough to solve the puzzle, you won, and then therefore you get to make the block. So one lottery ticket is one hash, basically. And there's nothing that prevents you from just getting as many lottery tickets as you want. So I think on the Bitcoin network, we have things measured in exahashes. So like a billion hashes per second are being tried. So that's an enormously huge amount of people trying, scratching the lottery ticket trying to win. And every 10 minutes on average, somebody wins that incredibly low odds lottery and they get to pick a block.
Okay.
So those are the differences. One is you actually buy a ticket with money, and the other is you kind of do some work to pick a ticket.
Cool. So I'm going down because I'm learning a little bit here too. So if the audience is cool with that, if not, type in a question. But so in the so one of the problems that people complain about with Bitcoin is it's slow.
Every 10 minutes you get a block.
It's 10
through.
minutes. So on proof of stake, is that inherently faster because everybody's bought the lottery ticket ahead of time?
So on proof of stake, you still have blocks, but you can set the block time to be a little faster. I think EOS is targeting I think it's 20 blocks per minute, so that's like 3 seconds a block. And they can do that because they know who won a minute's worth of tickets. So they draw 20 lottery tickets out of the hat and say, okay, for the next minute, these 20 people are going to pick the blocks.
Okay.
So they can have them every 3 seconds, and they're all sequenced because they know exactly what second their time is to do. So they can make that go a little faster. The argument on Bitcoin is that we don't need to wait for transactions to get into blocks, that if we did some kind of mechanism where what we said earlier, like the first seen rule was more enforced, that there was more kind of teeth behind it, that we could actually get away with doing zero confirmation transactions and then therefore have a experience of having fast transactions without actually having them be confirmed, and then let the lottery incentives kind of force people to go with the first one they saw. So there's some ideas about how to do that. I don't know if that's going to work or not, but that's kind of the direction the proof of work people are going in terms of like, how can we make this better? That's where the thought process is leading.
So this seems to be, would you say that this is a cultural divide in the cryptocurrency world?
I think it is actually a very strong cultural divide because the proof of stake people claim 2 advantages to buying the lottery ticket with money. The first is you're not burning electricity doing these hashes, so it's environmentally friendly, they say. I think that they have some validity to that argument. The other thing they will say is it can be faster, right? We can do the blocks a lot faster because we know who's going to do it. The proof of work people claim that proof of stake is less secure because if you're buying a ticket with money that's on a blockchain, the money that you have kind of validates the blockchain. That it's like circular, right? Because how do I know that I had the money? Well, I sent money to Alan, and Alan used it to stake. Well, what if my transaction didn't go through? Because who's staking them? You know what I mean?
Yeah, no, that's interesting.
There's so you have to do things like the money has to be sitting unmoved for 3 months before you can buy a ticket with it. There's crazy things you have to do to make it sort of work. Another complaint against proof of stake is that it tends to make the rich richer because if you have money to buy tickets, then you win more lotteries and your money kind of compounds almost like getting interest. Whereas with proof of work, you don't have that. You buy equipment and then you have to constantly be paying electricity to be making money back, and that equipment's depreciating and it's losing its value as new technology comes along. So you have to constantly run to stay in the same place. Whereas with proof of stake, you simply put your money up and you just kind of collect rent for free.
Well, isn't that one or the other? I mean, you're either spending money over here to be that competitive, or you're spending it there. It's
Right.
really, where you're putting your cash.
So those, I think those are philosophical differences that you see between the two camps. Wouldn't want to say that one camp is right or wrong, but simply that there are different ways of looking at it and different ways of approaching it.
All right.
The Facebook Live feed should be up.
Oh, cool. So we can
on the
actually see
actual
questions.
Yeah.
So
Refreshing the browser.
there is one thing that proof of work can do that proof of stake cannot, and that's proof of work can do SPV. So proof of work can have better security for phone wallets, theoretically, in a way
Okay.
that proof of stake has a harder time doing. I think that's the only really compelling argument I can see for one versus the other. All right. Well, I don't see our Facebook live stream. Oh, there it is.
Yep, I've got us up.
There we are. And what if I click this and I'm watching us talk and I'm also talking? Wow. It's like circular.
I believe we have a 7-second delay because occasionally I've been known to go blue. But nope. All right. So no questions. We got a big old smiley from Jay Payne.
Oh,
Thank
I-
you.
What about you?
EOS, support for the EOS token. Well,
Was that an advanced question?
that's not an advanced question, but I can answer that right now. We have investigated EOS. I am pretty familiar with the white paper, but we have not put any concrete effort or energy into implementing it into our code. So that's the short answer. Sorry. I read the white paper. I understand what they're doing and how it works and some of the cool things that are going on in that currency, but we haven't actually started work on integrating it yet.
Are we getting requests for EOS?
Not so much. I'd say there's a list of like currencies people are begging us for, and then there's like currencies that we hear mentions of, and I'd say it's getting up there. It's like in the mention it, like, but not like begging yet.
What are they begging for?
They're begging for Monero. I know there's some people who are very excited about potentially getting Monero, and then there's other people who like Ripple a lot too.
Okay.
But we'll see. We'll see where the future brings us on those currencies.
All right. So EOS for now is
It's
a
it's
theory.
on our radar screen. It's on our radar screen, but we're not like actively working on that one.
I do want to do more research on that though. I'm a little bit interested by it.
EOS?
Yeah.
Yeah.
Well, just from what I've seen, quick top level, trying to figure out what kind of apps to develop for.
I would say that Ethereum was the first like smart contract blockchain.
Right.
And then EOS looked at what Ethereum did and said, they made a lot of mistakes. Let's fix many of those mistakes. And
So we should really wait for whatever comes after EOS to really.
we will see. We will see.
All right. So next advanced question.
Do you want to read it to me, or should I ask?
Oh,
Should I interview myself?
I'm just saying if you're ready for it.
Oh,
I mean,
yes,
I was
I
ready
am.
to go. I was ready to go for it on the last one. And then out of the air, we heard something about EOS. It was amazing. So can you explain MAST?
Yes.
M-A-S-T, all capital letters.
Yes. MAST is an acronym that stands for Merkleized Abstract Syntax Tree. And once you know what the acronym stands for, it's pretty obvious what the idea is.
Oh, absolutely. I got that right away.
So this is an optimization that they're looking at doing for Bitcoin.
Okay.
So in Bitcoin, you can have smart contracts. They're not as smart and crazy as the ones you can do in Ethereum, but you can have very basic sort of conditions on who can claim money. So I can say, this money is spendable by Alan under these conditions, or it's spendable by Paul under those conditions. So I can kind of like put some money out there that two people could claim depending on who satisfies the puzzle first.
Okay.
So in a contract like that, there's a condition, right? If this happens, then that happens. Otherwise, do this other thing. Well, when I go to claim the money, one of those branches will be used and the other will be unused. So the idea behind MAST is if a branch is never even executed, we don't need to put its code on the blockchain.
Okay, so it's just kind of an optimization, like pruning.
Yeah, right.
Okay.
So it's a cryptographic approach. So it says Merkleized abstract syntax tree. So Merkleization or a Merkle tree is a way to have data that you know is cryptographically there, but you don't actually have to show what it is. And then abstract syntax tree is sort of the flow of code.
Okay.
So we're saying we're going to Merkleize the flow of code so that if a branch is never used, we don't even have to show what it is. We know it's there. We can verify it if it was used, but if it's not used, we can throw it away and no data is lost.
Right on. Very cool.
So that's an optimization that's potentially going to come to Bitcoin at some point.
So that is our word wealth word of the day, Merkleized. Vocabulary quiz next week. I learn a new word every day. That's great. All right. So what are bulletproofs?
Okay, so this is another technology that is being used on some privacy coins.
Okay. And when you say privacy coins, you're talking about things like Zcash or Monero? Or
I don't think Monero's specific. Does Monero use bulletproofs? I know that some of the...
Well, I mean, the concept of privacy
Right,
coins.
right,
I mean,
right.
this is an advanced question, but we do have non-advanced.
Right. So
listeners.
So the basic idea is in Bitcoin, if I do a transaction, everybody can see the to address, the from address, and the amount.
Right.
And so a privacy coin would be a coin that wants to obscure those three things. So there's different techniques. You can use ring signatures to obscure where the money is coming from. You can use mixing to obscure where it's going to. But the amounts, how do you obscure the amounts so nobody can see how much is being sent? Because if I didn't show you what amount I was sending, you'd have no way of knowing if I was creating money out of thin air.
Fair enough.
Right. I have to, the money at the end of the day has to all add up or we don't know what's going on. So there's something called confidential transactions, which are used on Monero and a lot of these other privacy coins. And the basic idea is to use elliptic curve cryptography. Now, you don't have to know what elliptic curve cryptography is, but it's basically a way of scrambling numbers. So they still add up. You can still do addition and subtraction, but I don't have to tell you what the numbers are.
Okay.
So I run it through this elliptic curve thing, and then you can still do arithmetic, addition, subtraction, but you don't know what the actual amounts were that I kind of ran through the thing. So I take the amount that I'm going to send, right? Take all the amounts that are coming into the transaction, add them up, and then subtract out all the amounts that I'm sending out, the miner fee and where the money is going to, and it should all add up to zero. Because I'm neither creating nor destroying money. So everything in minus everything out should be zero. They should balance each other out.
Right.
And if I use elliptic curve, you don't know what the amounts are,
But you get out.
but you know that the money is being created or destroyed.
Okay.
So that's cool. That's the basic idea behind confidential transactions. But there's another problem. What if I send my worst enemy -5 Bitcoins and then send myself +5 Bitcoins? It adds up to zero, but I just sent my enemy a debt and gave myself his money.
That's malicious.
Yeah, that you can't. So if you're going to do confidential transactions, you need to make sure of two things. One, that they all add up to zero, so money's not being created or destroyed. And two, that the amounts are always positive. So if we can prove those two things mathematically about these hidden values, then we know that everything's kosher and we're not like doing weird things with money. So that's like the basis of how these privacy coins work. Proving that a number is positive without revealing what it is turns out to be insanely difficult for various mathematical reasons. And what a bulletproof is, it's a way of doing that that's about 10 times smaller than the current state of the art. So before, the proof that a number was positive was like 4 kilobytes. So take this little transaction where it's like to, from, and the amount, and then like this little transaction here, and then this huge amount of data on top just to prove the numbers are all positive.
Yep.
So these transactions get really bloated. So the bulletproof says we can do that in 1/10 of the space, and it still works out mathematically. So that's kind of what those are. So those are kind of cool technology for privacy coins that are going to make the transactions a lot smaller and efficient.
Right on. Very cool. Oh, all right. So I like this next question. It appeals to a different part of my inner geek. But what is MimbleWimble? Can you explain that?
So I'm sure you're referring to the Harry Potter spell.
No, I was actually thinking Doctor Who, timey-wimey.
Oh, okay, okay.
Sorry, we're geeks. It happens.
So MimbleWimble is the thing I just explained to you, where the amounts are all obscured.
Okay.
And the idea is, instead of doing transactions where I say what's to and from and other kind of the Bitcoin style transactions, what if we just said everything is one giant transaction? Every block, all the 50 people who spent money in that block, or thousands of transactions in a block, it's all just money going in and money going out. And we can combine all those transactions together into one giant thing. So there's one transaction per block that's actually made up of everybody's transactions.
That seems very simple. Simple. So why such a complicated made-up word?
So the story behind this is...
I was thinking condensed transaction. No,
Yeah.
MimbleWimble. That sounds good.
So a paper appeared on a mailing list or an IRC channel. Just nobody knows who produced the paper, where it came from, or who wrote it, right? And it was just like the name of the author of the paper was Voldemort. Lord Voldemort wrote this paper, right?
Okay.
From Harry Potter. So nobody knows who it really was, but just Lord Voldemort wrote this paper. And he described, here's my idea for how to really make transactions really untraceable and confidential. We're going to take the confidential transaction idea and take this other cryptography from over here and mush it together, and we're going to design this blockchain that can do all this cool stuff. And then he just kind of dropped the paper and left. So no one's quite sure who did it or what it's about, but now that people are trying to actually implement it as a blockchain. There's a currency called GRIN, which is basically MimbleWimble implemented to see if we can actually make this pig fly.
That's hilarious.
So if GRIN comes out, it will be one heck of a privacy coin.
So do we know where that is in development?
Under heavy development.
Have they asked to be in our wallet yet?
No, they're like another year out.
Okay.
Yeah.
I love the name, Grin. Especially, you say MimbleWimble, you grin. It makes sense. All right. So moving on, we have a few more advanced questions. Do we have any from our audience at this time? So I'm looking at the... All right.
I don't see any audience questions, but I don't
No.
also trust the Facebook stream all the time.
Nope. I'm only seeing comments to help promote it and see it afterwards. So moving on. I'm hoping I'm pronouncing this correctly, but what are Schnorr signatures?
All right, this is another optimization that is being looked at for Bitcoin.
Okay.
So in Bitcoin, you can currently do something called multi-signature transactions.
Right.
So I can send money in a way that in order to claim it, there's a group of people that I'm sending the money to, like maybe the people who are CEOs of a company or presidents of or C-level executives of a company, right? So there's 5 C-level executives, and they're going to control the company's money. And I don't want just one guy like the CEO to take the money and run. So he's got to have consent of his buddies. So well, hey, any 2 of the 5 executives can send the money together. So by collaborating, you can send it out. So that's multi-signature. Right now, multi-signature transactions grow big. So if I have 5 people, that means they're 5 times bigger than normal transactions. Well, at least the script parts are. And the more people I add, the bigger and bigger the transaction grows. So Schnorr signatures let you do multi-signature transactions, but the size stays the same no matter how many people you are. So if you say, I want 100 out of 1,000 people together can spend this money, the transaction's no bigger than if it was a single person.
Cool.
So that's a really neat optimization based on some really nice math.
So this is a novice question that's not on there, but based on, we've talked about a few Bitcoin optimizations. I mean, how often do these things get rolled out to the network that is going to have an impact on the public perception of Bitcoin, and that it's you know, like I've had some friends ask me, so is Bitcoin is relative anymore compared to the other stuff that's going on? And so, like, I know we're getting a little philosophical.
Right. So what's up with the Bitcoin developers, right?
Yeah. So what's going on? Is that done? Is everybody moved? You know, these are.
Now this is my personal opinion. This is not Edge's opinion, right? Because I'm gonna get in trouble for.
Rather than cover up the logo. Okay, there you go.
I don't see the Bitcoin developers moving anywhere anytime fast. Bitcoin BTC seems to be an extremely conservative coin. They kind of want to maintain what they've got and keep it going as it is. And most of their effort and most of their energy is being focused on level 2 stuff, specifically Lightning Network. So they say the base layer is good. We have digital gold. It can sit there. It can be a store of value. We don't need to transact with it very much. It can just be the currency that sits in the vault while we pass around paper notes. Are you familiar with the history of currency and this money? We used to actually have silver coins. The coins that we would use to buy bread and buy groceries would be made of actual silver, like the metal.
Yep.
The problem is if you want to buy something big like a house or a car, you get these big bags of gold bricks that you're walking along, and bandits are like attacking your stagecoach. And
they weigh things like, what was it called again, a pound?
Right. So it was you're like, oh, okay, we need to pay someone in New York for this good or that they're going to send us. Well, okay, put the bucket of gold on the train and send it across, and they'll get their money in a week, right?
Yep.
So that was inconvenient. So we decided that it was better to put the gold in a vault, have it sit there, and I will pass you a paper that says you now own the gold. So the gold used to be mine. It's sitting in the vault. Now it's yours. You can go claim the gold when you want it. And then that became so much more convenient. Then the economy exploded, lots of productivity and good economic gains. But then at some point, the government decided, well, nobody really touches the gold that's sitting in the vault, so we can just say, nope, it's all gone. There's no more gold. Like, you can't trade your paper dollar for a gold coin anymore. And nobody noticed because no one cared. Everyone was using the paper. So the idea is we can do something similar with Bitcoin. Bitcoin can sit in the vault, not moved, just kind of be there. And then we can pass around these pieces of paper or Lightning Network tokens, basically, that represent the gold or the Bitcoin sitting there. And the idea is, unlike the paper money of old, we can't get rid of the Bitcoin because it's cryptographically linked to the Lightning tokens. That's kind of the thought. So unlike what the government did where they took away the gold backing, Lightning Network's cryptographically linked to Bitcoin. The Bitcoin doesn't have to move. It just has to sit there, but cryptography ensures that the system stays honest.
Okay, cool. So this kind of goes into the next question, I think, about, how do side chains work? Is Lightning Network like a side chain?
Kind of. It's different than a side chain.
Okay.
So one of the things that we've discussed is Bitcoin as kind of a store value. Like, Bitcoin is valuable. One Bitcoin is, what was it, $6,000 today or something like that? 6,500.
I don't have the current exchange rate.
Well, I'll have to check because it's different last night than it was this morning. Anyway, well, what if I wanted to do something really cool like Ethereum-style smart contracts using Bitcoin as the funding source?
Yep.
That would be nice, but the Bitcoin network doesn't do smart contracts like Ethereum does. It doesn't have that capability. So how can we kind of get the best of both worlds? The idea is we'll run another blockchain, a completely separate blockchain from Bitcoin. Kind of like Ethereum is a different blockchain from Bitcoin. But that blockchain doesn't have its own native currency. It has a representation of a Bitcoin as its kind of currency. So I can take Bitcoin BTC, transfer it to a sidechain, and now the sidechain can work with that coin. And if I ever want real Bitcoin back, I can transfer it back to the main chain and have it back.
Okay, so we do that for more of rapid transactions, or?
Right.
Okay.
So one example of a sidechain that is actually live right now that is being used is something called Liquid. It's a sidechain that was invented by the company Blockstream. They were the ones who came up with the sidechain concept and wrote the paper. And their Liquid sidechain is used to get money between exchanges more quickly.
Okay.
So if I've deposited Bitcoin BTC in one exchange and I'd like to move it to a different exchange because I'm going to do some arbitrage or whatever, I don't have to transfer it on the Bitcoin network, which can be slow and congested and plugged up. I can just transfer it straight from one exchange to the other using the side chain to do the transfer more smoothly. So that would be an example of a side chain. It's faster transaction times being a side chain type application.
Okay.
So I think the idea is we're not going to really enhance Bitcoin anymore. Bitcoin's just going to stay there. We'll look at these optimizations. Maybe we'll put them in, but for the most part, it's just going to sit there and we'll do all the cool stuff elsewhere. So I don't think it's irrelevant. I think they have an interesting strategy. I don't know if this is the best strategy, but it is certainly a strategy, and we'll see where it goes in the next years.
Right on. So as we've been going down these side chains and Lightning Network, gets us to our last advanced question.
Which I actually don't know the answer to.
You don't know the answer to. So let's see if the audience does. Does anybody out there know what William's thoughts on drive chain are going to be? So we'll table that one for next week.
Right. So I will tell you what I do know is that drive chain is a specific implementation of the sidechain idea.
Okay.
So the idea of running a separate currency that is still pegged to the value of the main currency. And it's a particular way of doing it. And I know the name of the guy who invented it. It's Paul Stork, but I haven't read his white paper on how it actually works. So I can't give you the details of how it works besides the fact that it's just a way of doing sidechains.
All right.
So maybe next time I'll actually have read that white paper and can give you more details.
All good. All right. So that was most of our advanced stuff. Do you want to take the time to do any? We have a backlog of questions, or we can go ahead and table it for next. There's one I kind of want to ask you.
Okay, awesome.
Just because I want to know too. And so if I plan on starting my own token, what blockchain should I use? Ethereum, EOS, Stellar, Waves, like what? And I know that's a tough question without giving you any more detail about what I want to do.
Right. So I would first say, why on earth would you want your own token?
Okay. No, with the constant addition of more and more tokens, I mean, at some point, we saw in traditional money consolidation of things like all these countries got rid of their currencies and went with the euro.
Right.
And now here we are in crypto world where we started with Bitcoin and now there's a lot
thousands
more.
of different
yeah,
coins.
And so fighting for like what's going to be useful. And so like I think that's a really good question that you would ask somebody, but why would you ask somebody like, why would you want your own coin?
Right. Well, I think that in the answer to that question, you would actually find the answer to the other question. Because if I say I am making a distributed autonomous organization, and that organization is going to be a smart contract on the Ethereum blockchain that's going to do betting or insurance or whatever kind of thing I came up with, then obviously it would be an Ethereum token because that's the platform that my smart contract autonomous organization is going to run on.
Okay.
Right? Like that's kind of the technological basis of what I'm building. So an example of that would be Augur. They have a predictions market system, and they have a token for their platform called REP. And because their predictions market runs on the Ethereum blockchain, REP is an Ethereum token. And it has to be because that's what it's for. And if you chose to build your product on EOS because you thought that EOS had cooler features than Ethereum, then it would be an EOS token. And if you said, well, no, my token is not for a smart contract distributed autonomous organization. In fact, my token represents shares in a very real world thing. Like I've got an apartment building in Manhattan that I'm going to be leasing out rooms, and you pay rent in this token, and you're going to own a portion of the building by having this token, and you collect rent. Well, in that case, you don't need a distributed autonomous organization. You need really kind of centralized control over this currency because it's representing a very physical asset. So something like a Ripple token might actually make sense for that because it's more of a securities and less of a smart contract.
So Ripple is doing tokens?
I believe that they are. I don't know the technical how to go and set up a Ripple token. But my understanding was that the platforms Ripple and Stellar were both kind of based on the idea of being a platform for different currencies to coexist and then exchange between each other.
Okay. Cool. So I'm going to take one last look at the Facebook feed and see if we had any questions. Question from Summer on YouTube. Okay. Will there be a way to spend crypto within the app like we used to be able to do in Airbits?
Oh, you mean like, so in Airbits, we used to have the coffee integration with Fold app, where you could actually go into the app, go to the spend Bitcoin, and then actually buy coffee gift cards, and I think Target gift cards too. Then we also had buy phone minutes inside the app. And the answer to that is, it's coming, but it's not a priority right now.
Would we do that within the wallet, or would we create a separate Edge app to kind of facilitate those types of purchases?
Well, we have in our app a plugin architecture, so we can have standalone kind of apps within an app. And that's how we're going to do our buy-sell integration. So in Airbits, besides buying things like gift cards and top-up minutes, you could also trade your Bitcoin back and forth for US dollars and other currencies. So all those features, whether it was buying gift cards or buying US dollars, were implemented as kind of like plugins. And Edge is doing plugins. Like we actually, or like 90% of the way there, we're actually, I think the next release will actually contain our first plugin. I don't quote me on that, but I think it will. So once we have a plugin, it's pretty easy to build more and bring those features back in. So I think the answer is it's coming, but we're more focused on getting fiat in and out versus buying things right now.
Okay, right on.
I am in talks with a partner who might potentially be our gift card person, but you know
Cool.
they're not ready for us either because they're swamped right now.
That's not a bad problem to have.
Yeah.
All right, we got one more from Jay Payne. What's the status of QuickBooks and CSV file exports?
I merged those pull requests. It's coming.
I worked on them. It is not as full-featured as Airbits for the initial release, but it will be by the next one. But we wanted to get basic functionality out, so you know, that will be in the next release.
Awesome.
All right, so I think that pretty much wraps up.
Wraps up our talk.
Yeah, it's a good 40-minute run. It's good to be back in town.
Yeah. I feel like I spent a lot of time talking about a lot of very...
Well, it was good. I learned a lot, and I hope that all of you watching later that weren't here for the live version will learn a lot as well, and send us more questions. We do this every week on Fridays at noon Pacific time. Not necessarily we as in me and William. That's a rare treat. But we have 2 team members doing the Q&A every week. So send us your questions.
All right. Thanks, everybody. Appreciate it.
Thank you.